Welcome to Homework Lib.
Okay, so here what we require is to set up antennas in our garage, right? Now the question says that the antenna should be located at a certain point P, right? And what we do is locate the antenna A at a point 240 meters. So let me write here 240 meters. Okay, here. So this is point A, the location of antenna A, and it is in the east of P. Now we place antenna B on the line that connects A and P. So at a distance x east of P, and it should be less than 240. So somewhere here, let's suppose B, which is at a distance x from P. Okay. Now the question says that the intensity is maximum at x is equal to 210, 216, and 222. So the intensity is maximum when the path difference PD is equal to the integral multiple of wavelength. Now PD, what is the path difference when x equals to 210? Then what is the path difference? Path difference is 240 minus 210. So that means 30 should be equal to m times lambda, right? So this is our first equation. Now when the next one is when x is equal to 216. So in this case the path difference is what? 240 minus 216, that is 24, and the value of m, since this is the next line, the next point, so we can consider this to be m plus 1, sorry, m minus 1, because the x is path difference is decreasing, right? So this should also decrease, value of m also should decrease, so m minus 1 times lambda. And another point is when x is equal to 222 and m further decreases, and the path difference is 214, 240 minus 222, that is 18, and the value of m is further decreased, m minus 2 times lambda, right? Now what we have to do is solve these three equations. If you solve these three equations, then easily you can get m is equal to 5, and which we probably don't require, and lambda equals to 6 meters. Okay, so we found out lambda. Now question asks us in part A, what is the frequency? So to find the frequency is the velocity of light upon wavelength, right? So it is 3 into 10 to the power 8 upon 6. So this is equal to 0.5 into 10 to the power 7, so almost 50 megahertz. So this is the frequency of the wave emitted by the antennas, right? Now part B of the question asks us, what is the greatest value of x with x less than 240 for the interference at P to be destructive? Now for destructive, the path difference PD should be m plus half lambda, where m goes from 0 to whatever you want, right? So PD, the path difference when there is the distance x, then the path difference will be 240 minus x is equal to m plus half times lambda. So x is equal to 240 minus m plus half of lambda, right? Now we want to calculate the greatest value of x, so x is greatest when this will be when m is least, because we are subtracting m, right? So that is equal to 0. So x equals to 240 minus lambda by 2. So what was lambda? 6, right? So 6 upon 2 is 3. So 240 minus 3 is 237 meters. So we are done with part B of the question. So the location of B should be 237 meters from P, such that the interference is destructive, and we have finished the solution to this.